students. I welcome all of you to today's science class. So today we are going to discuss about the chemical properties of metals and nonmetals, and in today's class we'll be discussing the reaction of metals and nonmetals with acid and base. We'll also be understanding what is displacement reaction. That means we are going to continue the same chapter, and this is the last part of the chapter. So first let us recall what we have learned. So in the previous class we have learned that generally when metals react with oxygen, they will form metallic oxide, and these metallic oxides are basic in nature. Some metals react vigorously with water, like in case of sodium. So it is stored under kerosene oil. Some metal reacts with water to form metal oxide and metal hydroxide. Hydrogen gas is released in this reaction. On the other hand, some metals react very slowly with water, like in case of iron. Oxides of nonmetals are formed when nonmetal react with oxygen. The oxides of nonmetals are acidic or neutral in nature and can turn blue litmus paper red. Nonmetals do not react with water. So now let's look at the objectives of today's class. So today's objectives are to study about how one metal displaces other metal. We'll also understand about the displacement reaction, and we'll find out how metals and nonmetals react with acids and base. So all these things we are going to cover in today's class. Even if you remember that in class 7 we discussed about a reaction between copper sulfate and iron. When iron nail is put in copper sulfate solution, reaction takes place and the color of copper sulfate changes from blue to green. So why did that change take place? Let us discuss in today's class. So this type of reactions are called displacement reaction. So what is it called? It is called displacement reaction. Now you need to recall the reactivity series. Here I have already written down the reactivity series of the metal, and depending on the reactivity of the metals, the displacement reaction takes place. Let us take some examples. On the board I have written 5 equations. In first case, copper sulfate plus iron. That means when copper sulfate reacts with iron, what is the product produced? So when copper sulfate reacts with iron sulfate and copper is produced. Let us look at the next example. When copper sulfate reacts with zinc, it forms zinc sulfate and copper. Now the third example, zinc sulfate plus copper. Here there will be no reaction. Similarly, in case number 4 and 5 also there will be no reaction. But why is it so that in these 3 cases there is no reaction? Let us understand. Look at the reactivity series of metals. Fine. So here what you see that iron has replaced copper and it forms iron sulfate. Now, look at the reactivity series and find out the two metals, copper and iron, the position of copper and iron. So, you will find that iron is placed above copper. So, here is iron and this is copper. So, you will find that iron is placed above copper. That means iron is more reactive than copper. So, as a result, iron can replace copper and form iron sulfate. Similarly, in number 2, copper and zinc. You will find that zinc is placed above copper. Okay. So, zinc is able to replace copper from copper sulfate solution and it will form zinc sulfate. Now, in this case, you will find that the metal zinc and copper, zinc is placed on top and copper is placed at the bottom of the list. So, this means that zinc is more reactive than copper. As a result, copper is not able to replace zinc. Similarly, here also iron is more reactive than copper, or we can say copper is less reactive than iron. So, it is not able to displace or replace iron from iron sulfate and no reaction takes place. And similarly, in the fifth one also, iron, if you can see, iron is less reactive than zinc and as a result, we cannot replace zinc from zinc sulfate. So, what can we conclude? We can conclude that one metal can replace another metal only if one metal is more reactive than the other. And the more reactive metal will only replace the less reactive metal. Less reactive metal cannot replace more reactive metal. Okay, so this is what we understand by displacement reaction. It is a reaction in which more reactive metal displaces or replaces a less reactive metal. So, this is how the displacement reaction takes place. So, children, I hope that all of you have understood the displacement reaction. Now, let's move ahead and understand about the reaction of metal and non-metal with acids. Now, let's start with a discussion of an activity. If we take some samples of metals and non-metals in a test tube and add dilute hydrochloric acid to each and every test tube, and if we observe the reaction that takes place, we will find that the reaction which is taking place is different. Now, in case if no reaction takes place, we need to warm it a little bit and then bring a burning matchstick near the mouth of each test tube. So, you will find that the burning matchstick burns with a pop sound when it is brought near the mouth of the test tube which contains metal. But such sound is not produced when it is brought near the mouth of the test tube which contains the non-metal. So, what do we understand from this? We understand that metals react with acid, but non-metal do not react with acid. Yes, metals react with acid, but non-metals do not react with acid. So, let's see how metals react with acid. Let us again look at the reactivity series. So, it will help us in understanding the reaction between metal and acid very easily. I think you are clear that non-metals do not react with acid. Now let's see how it reacts with metal. Metal reacts with acid to produce metal salt and hydrogen gas. And the pop sound which is heard when the burning matchstick is brought close to the mouth of the test tube is due to the presence of hydrogen. So let's take some example. Sodium, when reacts with dilute hydrochloric acid, it produces the salt sodium chloride and hydrogen gas. Similarly, when magnesium reacts with hydrochloric acid, it produces magnesium chloride and hydrogen. Another example of aluminium reacting with hydrochloric acid produces aluminium chloride and hydrogen gas. But in the fourth case, you see that copper do not react with hydrochloric acid. Yes, no reaction takes place. Why does that happen? You'll find that sodium, magnesium, aluminium are placed above the hydrogen in the reactivity series. Yes, so the metals which are placed above the hydrogen in the reactivity series will react with acids because here sodium is displacing hydrogen to form sodium chloride. Similarly, magnesium is replacing hydrogen to form magnesium chloride. And I have already mentioned that it depends on the reactivity of the metals whether a metal can replace or displace another metal or non-metal. Fine. So hydrogen is a non-metal. So sodium replaces hydrogen because sodium is more reactive than hydrogen. But in case of copper, you will find that copper is placed below hydrogen. That means copper is less reactive than hydrogen, and as a reason, copper is not able to displace hydrogen from hydrochloric acid and no reaction takes place. So this is how metals react with acid. Children, now let us understand how metal and non-metal reacts with base. If a freshly prepared solution of sodium hydroxide is taken in a beaker and a ball of aluminium foil is dropped in it, after that, if a burning matchstick is brought close to the mouth of the beaker, we will again observe that the matchstick burns with a pop sound. So remember children, why it is burning with a pop sound? Because it produces hydrogen. It indicates the presence of hydrogen. So when metals react with the base like sodium hydroxide, it produces hydrogen gas. But remember children, not all metals react with base. Now if we talk about the non-metal reacting with the base, we'll find that not all non-metals react with base. Only some non-metals will react with base and it will not produce hydrogen gas. Above this, it is a very complex reaction. So you will be learning further about the reaction of non-metal and base in higher class. We know that everything present around us is made up of one or another substance. And if a substance cannot be broken down further by chemical reactions like electrolysis and by cooling or heating, that means it is an element. Oxygen, hydrogen, nitrogen, sulfur, aluminium, all these are examples of element. An element is made up of small unit called atom. And the atom of different elements are different. But if we change the physical environment, the atom of an element will remain unchanged. For example, if we take liquid sulfur, the atom present in the liquid sulfur will remain same as that of solid or vapor sulfur. That means the atom of an element will not change even if the physical surrounding or the physical state is changed. So, I hope that all of you have understood today's class and the topics which we have discussed in today's class. This is all for today. Now let us summarize what we have learned. So in today's class we have learned that a more reactive metal can replace less reactive metal to form new compound. A less reactive metal cannot replace a more reactive metal. Metals react with acid to form metal, salt and hydrogen. Nonmetals do not react with acid. Metals react with bases to form salt and hydrogen gas, but all metals do not react. Some nonmetals react with base, but no hydrogen gas is produced and it is a complex reaction. So children, this is all for today's class. Hope you have understood whatever has been taught in today's class. Thank you and have a great day.